recording. All right, and oh, my CPU is crashing. Screen. Awesome. Can everyone see my screen?
Yeah.
Excellent. So the subject of today's talk is this lovely little piece of code in my bottom right, which probably looks pretty unreadable right now, but I'm very proud of it. I spent probably a couple hours working on this. What it does, I'll explain what it does before we work out how it does it. What it does is, this is in test code. I got tired of writing the same thing over and over. It's create a parser. For context, I wrote this for testing my compiler for RCC. And the compiler has like a very set format. You make a parser, you parse something, you create an analyzer, you analyze something, and if it worked, you return the result. So this is like a nice little design, but it makes the testing like really annoying to write because you're always doing the same thing. So I was like, okay, is there any way I can like write a function to abstract over this? Because, you know, it's programming and we love abstractions. But it ended up being a bit more challenging than expected. I'm going to leave that up in the right. And in the meantime, we're going to look at some simpler things. So is everyone like familiar with generics? Like Java has generics, Rust has generics. They're not exactly the same, but they're pretty similar. You like abstract over data types. So you have like a vec of usize. It's like an unsigned integer. And you add things to it, and this vec.push like works for all types that it contains. It doesn't have to be a usize. It can be anything else. So that's generics in a nutshell. And normally when you think of generics, you think of container types, like a vector or a hash map or that sort of thing. But it doesn't have to be a vector or hash map. You can also abstract over functions. I did not do an example for that. We're going to do the currying example instead. So let me just write one up real quick. So say you have, like, actually I have real code I can use for this. What you do is, say you have like one function that you call in between. Oh, I do have an example I thought of. I'm so sorry. Yeah, so left associative min-op, here we are. This is not a great function. It's kind of more complicated than it needs to be. But the idea is you have this like pattern you use over and over, right? While some condition is true, do something else. And you're like, well, I don't really want to write all that code out. Could I abstract over it? So you can actually pass a function to another function. This is called first class functions. And what it lets you do is it lets you build like these really strong abstractions. This is how iterators work in Rust. You do like iterator.map, and you pass it a function, and for every element in the iterator, it will do something. Where's map? Here's map. If you know like Haskell or something, this is like super common in functional languages because they don't have mutation. But it's also useful in languages with mutation because it lets you, instead of writing out the whole loop, it's kind of like simpler, like this. Anyway, so that's the idea behind first-class functions. This one is kind of a complicated function. So in C, a really common pattern is you have like x plus y, and then this repeats arbitrarily many times, right? You can have as many pluses in a row as you want. So the way I parse these in RCC is called recursive descent. So there's a separate function for each operation. Plus is a separate operation. Times is a separate operation. Modulo is a separate operation. There's all sorts. And if we go through the file, well, if we go back a little ways, hold on, then you can see there's like 100 different functions. It's pretty bad. One for each grammar rule. Anyway, we'll come back to that. But that's what this function is doing. Is it's doing, you know, operations over and over in a loop. And I was like, if I'm writing this 1,000 different times, why am I writing the same code over and over, right? So this expression function here is a function. I was like, okay, let's abstract over this. Let's take in these two expressions, one on the left and one on the right, and do something with them. And turn that into an abstraction. So the abstraction here is experfunc. This is a function that takes a left expression and a right expression and the type of the expression, so like the token here would be plus, and it emits another expression. So an example, I don't have an example of usage. An example usage would be like left dissociative binary op, which is a terrible name, and I'm so sorry. And then the next grammar function would be like parser. So the way parsing works is you have precedence. So like addition has lower precedence than multiplication. So for addition, you'd pass in multiplication as the next stop. I think this is what I called it. It doesn't super matter. And you would pass in the tokens that you want to match. So it would be like token add or something like that. And you'd pass in the function that analyzes this. So like parser, I don't know, analyze addition. Something like that. And you see here it's like super concise and like easier to read than if I typed out this whole loop. And the other thing it's doing here is it takes two different functions of different types. So if you look here, you're like, what's this function and function mute? What's the difference between the two? This is because Rust has, because of the borrow checker, essentially. So what function mute lets you do is, oh, I haven't explained what function is. So function is something that lets you abstract over both function pointers, which is what you have in C, and closures, which are more common in like JavaScript and like functional sort languages. So here's an example of a closure. Like takes two parameters and it returns like some other value. So this says take A and B and return their sum. Whoop. And this will print out 3. It's just adding the two together. And what function lets you do is it lets you abstract over both closures and like function pointers. So function pointers, I just write it out as a function. Like that. The difference between function and function mute is that for a regular function, for this guy here, it is not allowed to mutate its environment. What I mean by mutate its environment is, say you have like an accumulator, right? And you're like taking the sum over everything in an array. Let me make this a separate part. What you could do is you could do, like, say you have a vector of something. Or actually, let me do 0 to 10 or something, right? And then for every element in that, you take it and you add it to the accumulator. You can't do this like with the normal function because where does accumulator come from? It's not like a parameter to the function. So what that means is this closure right here is function mute. It mutates its environment. Let me make sure this compiles. It does not compile. Oh, well, because I didn't annotate types. Boo. Anyway, so that's function and function mute. And that's sort of the idea we're going for here, is we're abstracting over things with first-class functions. Questions before I go on? I'm going to go with no questions then. Okay. The next thing we're doing is lifetimes. So one of the issues I ran into with RCC is I want to have like include files, like header files, right? Include standard.io.h, something like that. The issue here is that I had two separate things I wanted to do with the file. I wanted to store it. This is self.files here. So I knew how to like print it out at the end, like for error messages or something. I can take, some segment of the file and print it out, and that's the error message. But also, I need to go over every character in the file to parse it. So that's what this lexer here is doing, is I'm saying, okay, give me the last file that you just added, make a new lexer out of that. And this code does not work. If I try and compile it, let's see, what did I call it? Referential. It gives you this really awful error that is kind of scary to read. It says, can't infer an appropriate lifetime. So what is this saying here? It says the lifetime can't outlive anonymous lifetime on method body. So method body is this function here. An anonymous lifetime is the lifetime of the function. So that lifetime ends when the function ends. Think of like local variables or something. And then secondly, it says it must be valid for this lifetime A. So what's A? We wrote that in the code here. A is the lifetime of this lexer. And the lexer lives as part of the preprocessor. So if we have the lexer as part of the preprocessor, then obviously it needs to live longer than this scope because the preprocessor lives longer than this scope. So what can we do? And it gives us like some more details here. Well, the issue here is this borrow here that we have, self.files. This borrow is only valid until the function ends. So we can make that a little clearer by making it like a separate variable, right? This will give us exactly the same error, assuming I did things right. Yep. It says this borrow only lives until the end of the function. So how does this work? I tried all sorts of different things. Actually, I'll paste this in chat so people can see. I tried all sorts of different things. Python dude, am I not in streamer mode? Is that something I have to enable explicitly? It says enable.
That's for, like, Discord won't make noises, basically, is what streamer mode is. So, like, won't interrupt your video, so you don't need it on or off, it doesn't matter.
No, okay. Alright, so, yeah, it's the link I posted is me trying very hard to get this thing to work, and it just did not work. This is not the correct link. Here we go. And basically what people are saying is use an RC, and I'm like, what's an RC? So what RC means in Rust is a reference counted something. It's another generic container. Standard RC, there we go. And what it means is it keeps track of the number of people who have access to it. So when you like create RC new, it says, okay, the count of people with access is 1. And when you do clone, think of like a copy constructor. Sorry about the noise. Think of like a copy constructor in C++. When you do clone, then it increments the count by 1. It says, okay, one more person has access to this. And since Rust has RAII, that means that the reference counter won't be dropped until all the people that have access to it have like dropped the pointer. So all of them need to drop it before the inner value is dropped. So what that lets us do, referential fixed. If we create a new reference counter from that file, since we don't need to mutate it, since we just need to say, all right, this exists and we all just need to look at it, since both of these have access, we don't need a borrow. This is, instead of being a borrowed value that only lasts until the end of the scope here, it's an owned value that lives as long as we want it to live. So if you see here in the preprocessor this lifetime annotation that we had before, this lifetime annotation that we had before has gone away because it's no longer about borrow, it's an owned value. Wrong chat. Questions on like RC and why that fix works, or what the fix was doing? Yes, no, no? Okay. So the next thing I want to talk about was a different error I ran into. This one gave me so much trouble. I had no clue what was going on. And what this is doing, this was like the main entry point from the compiler. So we're compiling, and we take in a search path, which is like the places to look for, a header. So maybe it would be like user include, and then maybe the current directory, and then some other random spot. And they have some lifetime here that might not be the whole program. And then we have the files. So the files here is like where we store the files that we've read off of disk. So those would be things like user include standard.io.h would live in this files here. And we run this, and I like create a preprocessor that does something with all these arguments I pass it. And I finish with the preprocessor. And then I try and do something else with the files. And here's the crazy thing. This does not compile. despite the fact that these things were not consumed by the function, and that the thing returned from the function has now been dropped. Right? What's going on here? Why wouldn't this work? This thing no longer has access in any way to the parameters we passed in. So let's look at the error. It says you passed in lifetime short. Mutable borrow occurs here. Requires that files is borrowed for short. Well, that seems a little odd because we didn't say that files was borrowed for short. We said it was borrowed for something else, something that outlives short. It lives longer. So why is it giving us this error here? So this took me far longer than I wanted to figure out. I'll put this link in chat as well. I have too many keyboard shortcuts. The issue here was that in the other part of the code, in the F here, we named them as having the same lifetime. We said it iterates over something with lifetime A, and it takes this, which has lifetime A. And so what rustc is thinking is that these have to be equal. It's not that func lives longer, it's that it's exactly the same as short. So when search path gets dropped, because search path doesn't live very long, it thinks that files can't be used anymore. And when I say search path is dropped, I is an owned value, even though it iterates over things with that are borrowed. So it is in fact dropped after we drop the preprocessor. So because we dropped search path, and because the compiler thinks that the search path and the files have the same lifetime, it won't let us use these after, even though there's no reason that we couldn't. So does anyone have a guess what the fix is to this? I felt really dumb when I figured it out. The fix is you change this A here, I think it was this one, to be an anonymous lifetime. Literally, that's all you do. And now it compiles. Because the difference is that now it's no longer requiring them to live for the same amount of time. It's saying, all right, since we said it outlived it here, it's okay for the search path to be dropped before the files are dropped. This took me ages and ages to figure out. Okay. Questions before I go on like lifetimes and why the fix worked?
So you're able to have multiple things called prime A or apostrophe A?
Yeah, apostrophe A is the lifetime here. And I said they both had the same lifetime, which is not what I wanted, but what I wrote.
Okay.
Alright. The next one I'll do is, I already did that one. Okay, we'll talk about this one for a bit, and then we'll have more time to discuss it. So, going back to the parser, this analyze function, I was super proud. It's even the letters spell out the word parse, because it's analyzing and parsing, and anyway. So, it takes some input string, which is like a bit of C code, right? Maybe it's like an expression or something. It takes some parse function, it's just like a function that takes the parser and outputs some value. We don't know what that value is. It has type S, and that's the only thing we know, is that it has type S. And then it takes another function that takes in that S, the output from the parser, and returns R. R is like result here. It's the output that we wanted to get originally. And so it takes in P, so P is the function that takes the parser and outputs S. A, which is the analyze function, which takes in the analyzer and the output from the previous function, and returns R, which is the result we want. So this is, I was talking with, I think Charles or Philip last night, and I was saying this is like type level programming, right? The actual code for this is really dumb. It's the types that are very confusing. So what this lets me do is at the call site at analyze, this is like really easy to work with. It's analyze and then the code and then like two function names, as opposed to, writing out 6 lines every time, which was getting annoying. I spent far longer than I should have, because I could have just copy-pasted the code, but I really wanted to get this working. Oh, and then error here. So the other thing I wanted to do... No, I don't like macros. Macros are, like, specialized. I don't know. And the other thing I wanted to do is all of these returned, like, different types of errors. So if you see here, this parser returns E. We haven't set in stone the type of E. It's another generic parameter. All we constrain for E is that it has to... you have to be able to turn it into this struct error somehow. So in RCC, what this corresponds to, if I can find the code, is I have like a generic, like let me just pull up the code. There's like semantic errors, and then there's syntax errors, and then there's lex errors, and all of them are separate. There's also like an overall error. Here it is. Yeah, so this is the same error that's in this function signature. And then there's like subtypes, so semantic errors, syntax errors, and so on. And a lot of these functions didn't actually return error, they would return semantic error. And I was like, well, typing .into is really annoying, so let's see if we can do that. Let's see if we can do that in the function signature as well. Because if you don't know Rust, this like little question mark here means return it if it's an error, and also call into, so in Rust, into means like convert one thing into another thing. It's not coming up. There we go. So, for example, you can always convert a 16-bit integer into a 32-bit integer because it's a proper subset. And in the same way, you can always convert a semantic error to a compile error because it's all semantic errors are compile errors. So that's the other thing that this is doing here. And this where clause is just saying there's too many types for me to write them all in this function signature. So this code also does not work. I'm gonna give you an example of that. This is the worst error message I've ever gotten from the Rust compiler. It's just so bad. So it says type mismatch, found signature of 4 and then a lifetime parameter, function taking our mute parser, and then expected signature of 4R, and S is another generic parameter, taking parser preprocessor S. And this just makes no sense. And the reason it makes no sense is because in both cases, you have a parser with the same lifetime. Like, the only thing that's changed is this preprocessor is a borrow. Like, why does it care? And it gives us, like, basically the same error benchmark. Oh, and it says expected bound lifetime parameter found concrete lifetime. And I had no idea what this error message meant. Let me pull up the other link I have. All these questions I, like, ask in Discord because there's smarter people than me in the Rust Discord. So I went to here, and I'm like, does anybody know what it means to have a bound lifetime versus a concrete lifetime? And people were like, where was it? Okay. With a bound, you're allowed to pass in a longer lifetime than required. So what does that mean? So concrete lifetime means it's an exact lifetime. So I have to think through this every time I read it. We passed in a lifetime of S, but it expected like a range of lifetimes. So if we see here, it expects to take any lifetime, any S, but we said it was a concrete S. I still don't think this error message makes any sense, but... And then it gives the same thing a couple more times. So let's look at the function again. What we said is that it takes a preprocessor, and that it's a borrow. But if we look at the definition of preprocessor up here, preprocessor actually has a lifetime parameter on it. It says it holds a string that lives for some amount of time. For A is the lifetime. And what's going on here is it's taking this A, and for some reason I don't understand, turns it into this. This gives us the same error. So it's like eliding the type is what's this called. It's inferring some type. And the fix to this is you change this elided type to be a specific type. Well, and then you have to say that this type exists. So here's that type. And then now it works. So this is kind of black magic. I think the fix here is that we said it was the same lifetime for both, as opposed to a range of lifetimes. But I'm still not quite sure why it works. This is at the limits of my knowledge. So, and then, oh, we didn't need to say that it lived longer. Anyway, so yeah, that's the difference here, is that we said they have the same lifetime instead of inferring the lifetime. Questions on that? Oh, Philip had a question. By providing a specific bound lifetime, that placates it. Yes. Yeah, you're saying it's this exact lifetime that is the same for both, as opposed to having like some range of lifetimes. Philip has a question. I believe so, and we could test that by adding in a separate lifetime here. So I'm going to change this to be like a B instead of a C. Yeah. Yeah, if we change that to be 2 different lifetimes, then we get the error we had before. Well, slightly different, but similar. It's saying instead of a specific lifetime, we had an anonymous lifetime. Okay. Other questions about how this works and why I thought this was a good idea? Or other Rust things. I can answer other Rust things. The other thing that came up earlier, I think yesterday, I can't find it anymore. I put it in the chat. Currying. Here it is. Someone's like, how does currying work in Rust? So currying, if you don't know what it is you have 2 functions, and you're like, well, one of these functions is really like a specialization of the other function. Like, what if I could like reuse that instead of rewriting the whole body? So this is an example of that. You have add, and it takes in 2 parameters, A and B. And then you're like, well, if you, this would be like ++a in C or something. Well, that's really just a special case of adding, right? So you make increment like fall back to add. You're saying like add is, increment is a special case of add. And yeah, that's currying in Rust. I forget how I got on the topic. Oh, so Conrad had a question. Philip had a question. Is there any general strategy for debugging lifetime errors? Not really. What I generally do is I just kind of play around with it for a while and see what works. So I do generally try and add lifetime annotations, like the more complicated it gets, because as you can see from like these 4s here, like where did the 4s come from? And so if you add those explicitly, sometimes the error messages will get a little better, but it's still like not, I have to fiddle with it every time. While I'm on that topic of 4s, let me explain those. I think it's higher kinded lifetimes or something like that. Yeah, you have more control, but you also have more room to shoot yourself in the foot. As you saw from the example where like I said they had the same lifetime by accident. So higher ranked trait bounds, there we are. Yeah, there it is. Thanks, Python. So Yeah, if you explicitly say the lifetimes, then it's easier to see what's going on, but you might actually change the semantics by accident, because so many of the lifetimes are inferred. And let me give you an example of how it infers those. Lifetime elision, I think, is the one I want. The Rustonomicon is great for this stuff. Yeah, so since in order to make common patterns more ergonomic, Rust allows lifetimes to be elided. So say you have like a function taking an s, it'll automatically infer the lifetime for this because it's just any generic lifetime. And the same thing for like these other common patterns. It'll infer, oh, if it takes in a borrow and it outputs a borrow, then they must be the same lifetime. So what you have to do when you make those lifetimes explicit is you have to make sure the ones that you write out are the ones that the Rust compiler inferred, because if they're not the same, then you'll get different behavior, get like a different error message. Right, so higher kinded lifetimes. The use case here is that you like have a closure you create, right? You have that anonymous function from before, and you want it to outlive this current scope. You're returning a closure from the function. Let me type up an example. I don't like its example. So like say we have function f, and it takes in 2 numbers, and it returns a function that, when you call it, will return a number. So you can think of it sort of like lazy evaluation in Haskell, actually. So when you call it, this means a closure that takes no parameters. It will return a plus b. Right, and so immediately we see... actually, the issue is that I didn't... So this is the other thing that pops up with closures, is by default, this will be a borrow of a. So we have a, it lives for this function scope, but if we try and borrow it in something that we return from the scope, then Rust doesn't like that. And so what you do instead is you move it into the closure. And this says instead of borrowing it, we want you to like copy it into this closure. Well, not always copy it. It depends on the types. I forget why we needed 4. I'm going to look for the Stack Overflow, because the Stack Overflow had a really good example. Whoop. Oh, I think you might be right. Let me try that real quick. So let's say we have, like, returning a reference from an impl function. Do you have an example for that? Because I feel like I've seen this before. I just don't remember now. Anyway, the idea behind 4 is you have something... Here we go. If you have filter on option. So what filter does is it... Sorry, I have to explain option first. Option is like... if you think of optional in C++, it's the same idea. If it's some, then it's not null. If it's none, then it's null. And filter is like, okay, take that sum we had, and only does it, and only returns something if this function is true. The last paragraph of the Nomicon page. Here we go. Okay, so it returns a borrow that lives outside the scope of the function. Here we go. So this is a struct that has some data, and it's returning a reference to that data, but that reference lives longer than the scope of the function. It lives as long as the struct here, the struct closure. And so actually, if we try and do this like without all the fancy syntax, and we like copy paste it in. I'm gonna delete all these types. The issue is that the borrow will outlive the function scope. Well, I have to tell it the type of f. We had that somewhere. Ugh. Function, here we are. Right. And so this will give us an error because it's outliving the functions. Well, no, Rust is inferring too many things again. The issue is if you do that like with normal lifetimes, you don't know what the type signature should be for this function that you passed in. This function, it takes in some lifetime. What lifetime should that be? Yeah, the problem is you can't name the lifetime until you enter the body of the call, which doesn't work because you could have you can't name the lifetime because it's not the lifetime related to the function. It's a lifetime that's related to the struct, I think. And so anyway, the way this desugars is to for-a. And for-a means this works for any lifetime that doesn't have to be something like a specific lifetime. It can be any lifetime that you've passed in from the struct. Questions on that? I know I did not explain that very well. Okay. Well, I think with that, unless people have questions... Yeah, Coulter has a question. Oh, I'm not sure. This is from MDBook, so this is the default one, but MDBook is this guy here, which is used for a lot of the Rust documentation. So it's kind of neat. I'll post that in. Other questions about Rust or lifetimes or crazy things in the Rustonomicon? Alright, I guess I'll wrap it up then. Thank you so much for everyone for coming out.
Thank you, Josh. Appreciate it. It was interesting.
I know it wasn't explained the best it could have been, but thank you.
Yeah, that was cool.
That was pretty cool.
All right.